Alhamdulillah, assalatu wassalamu ala rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear viewers, my name is Al-Haque. I am a power electronics engineer. I have intended, inshallah ta'ala, to upload some videos on power electronics tutorials. My videos will be including, inshallah ta'ala, converters. In the beginning I'll do the inshallah DC-DC converters, and that will inshallah include buck converters, buck boost converters, boost converters, and I have intended to explain them, how they work, what are the functionalities of each and every elements, what are the waveforms should be looking like, and derive the necessary expressions for that. And then inshallah we will like to move slowly to the control system of these converters, because at the end of the day you want to know how these converters could be controlled in power electronics. And inshallah ta'ala, I would like to present something in future, if obviously Allah wills, something on motor drives. So let me tell you one more important thing. I would like to tell you something about power electronics. Power electronics, as you guys already know, that it's an interdisciplinary course. It takes a very good knowledge of electric circuit. It takes a very good knowledge of calculus. It takes also, if you do the control system, definitely it takes a good knowledge of control system. And if you want to do other than that, if you want to go to the motor drive, it obviously includes the knowledge of electric machines, or probably the advanced electric machines. And at the end of the day, definitely these controllers which you are designing for power electronics applications, you need to work them in digital domain, so therefore you need a course of digital signal processing. And somewhere in the job, maybe being a hardware engineer, you might have to know a very good knowledge of programming, which might include C language, microcontroller programming, so on and so forth. So in the beginning I have decided to do some DC-DC converters. So in order to understand the DC-DC converters, let's look at very simple circuit of a DC-DC converter, which is introduced here, right here in this page, as you can see, inshallah. I have a circuit here. This circuit has a DC voltage source as an input. It has a switch and a load as a resistor. I specially put a resistive element here which in the beginning it is very easy to analyze. So in the circuit, this is a switch. Actually, in any DC-DC converter, you will see the configuration at the end of the day. It is like this circuit. So this is a switch in the DC-DC converter. If it is the main switch or the active switch, as we say, it should be operated in some given frequency. It could be 20 kilohertz. Usually it's sometimes you don't want to go to the 20 kilohertz exactly. You might want to do 25, 50, 100, 200 kilohertz. So it is, let's say it's operating at some given frequency. So and the input voltage is a straight line with respect to time, which is a DC voltage source. So let's see what happens with this circuit. So when the switch is on, that means when the switch is closed, as it is a switch and we assume it's an ideal switch. By the way, I want to say in power electronics in the beginning it is very important to analyze everything when everything is assumed to be an idealized version, because when it is something ideal, those who are the beginners, it's easy to analyze it. So let's assume the switch is ideal. What I mean by ideal is that the voltage drop when the switch is on, the voltage drop across it is essentially zero. So when the switch is on, potential of this point will be equal to the potential of this point as the switch is ideal. So if you apply Kirchhoff's voltage law around this loop, this will be minus, this will be plus. This plus is falling here, so it's a plus and minus, and it's a plus and minus here if a current flows in this direction. That's how it is usually. So if you apply the Kirchhoff's voltage law, you see that VD becomes equal to the V switch plus V output or VO in this situation. V switch, I mean the voltage drop across the switch. As I said, in the ideal situation, the V switch equals 0. So plug that into that equation. You will find out V switch equals 0, so that VD becomes V0. So that's what it is written here. V0 equals VD when the switch is on or closed. Now when the switch is off, means this is open. Therefore the circuit here, actually the complete circuit is open because there is no current flowing through that. There is no path for the current to make a complete loop. So therefore, as this is a resistor, therefore potential of this point, there is no current flowing through this resistor, so therefore potential of this point is equal to the potential of that point, which essentially implies that the voltage drop across the resistor is also 0. When the voltage drop across the resistor is 0, if you apply again the Kirchhoff's voltage law around this loop, you will see that VD equals V switch plus V0. Substitute 0 for V0, so you will get VD equals V switch. So if somebody asks you how would I choose the switch in this situation, you would say by the voltage I would choose it in this situation by the value of VD. As when the switch is off, it has a voltage on it which is equals to the VD. Now, having said that, as we said before, the switch is being operated with some definite frequency. So we will see, let's say it is given some frequency, I don't know, let's say it's like 100 kilohertz. So when the switch is on, as I said, let's go to this diagram first, I'm sorry. When the switch is on, the output voltage equals VD. So from here to here, if I assume the switch was on, this is my output voltage, which is equals to VD. Now when the switch was off, let's say from here to here it was off from this much time. For this much time the switch was off. We said we have derived that the output voltage equals 0. So here is it. here is the 0 line which is at the ground. So therefore the VO of t, or the instantaneous value of t, is becoming Vd for the period of 0 to t on, if this is 0 and this is the time, let's say it is t on. So from 0 to t on, VO equals Vd, and from t on to t off, VO equals 0. And then again we turn the switch back on, so it becomes, the output voltage becomes Vd, and then again we turn the switch off, it becomes V0. So if this is my switching period, when I say switching period, means one complete cycle. One complete cycle means the one time the switch is on, the another time definitely the switch is off. That's what it means. So T will become then T on plus T off. Well, unfortunately this what I wanted for today. It's a very short video. Thank you very much for watching it, and Alhamdulillahi Rabbil Alameen. I'll see you next time.